peace be upon you, grade 7 students. Today we are going to start with Chapter 3, Respiration of Living Beings, Worksheet 21, Respiration in Aerial Medium, Part 2. At the end of this video, you will be able to identify the type of respiration in insects, explain how gaseous exchange occurs in insects, list the characteristics of the air sac that favors the gaseous exchange. Prepare your worksheet, your copybook, and a pencil. In the previous session, we learned about respiration in insects. We said that the respiratory movements can be noticed from the regular movements of their abdomen. It lowers during inhalation, while it raises during exhalation. And the air enters and leaves their body through small openings or holes, which are called spiracles. Like humans, insects respire in aerial medium. But do they have lungs? What is their respiratory organ? How does the gaseous exchange occur? What are the parts of the respiratory system in insects? Let us watch this video that shows the organization of the respiratory system in insects.
You can see how the tracheal system is broken down. We have the tracheae, where there are two tracheas down either side of the insect's body. We have the tracheals, which are smaller branched tubes that take the oxygen directly to the muscle tissues. And then on the outside of the body we have spiracles, which are a little bit like stomata in plants. Let's have a look at this a little bit closer. Here we have the spiracle. Again, look how similar it is to a stomata or a stoma in plants. That's to control water loss, but we'll get to that. Here's the trachea, the main oxygen-carrying tube. Here are the tracheals. Look how they branch towards the muscle fibers. Now at the bottom of those tracheals there will be a small amount of fluid that the oxygen can dissolve in and thus make diffusion to the muscle fibers a little bit easier.
After we watched the video, now we are able to indicate the main part of the respiratory system in insects. It is the trachea that branches into smaller tracheals. Here are the spiracles, which are the structures that the air enter or leave the body of the insect. Now answer number 1 in worksheet 21. Give the role of the spiracles. The spiracles are openings that allow the air to enter and leave the body of the insect. Pathway of inhaled air in insects. So how does the air enters the body of the insects? Through which structure does it enter? And what are the parts that the air can pass through them in order to reach the body or the organs of the insects? Let us answer number 2 in worksheet 21. So the air that is rich in oxygen gas enters the body of the insect through the spiracle. Then it passes through the trachea and branches into the tracheals till it reaches finally the muscles. Now when we want to write the answer of number 2, don't forget to use arrows in order to show the path of the inhaled air from the spiracles to the muscles. The first objective is to identify the type of respiration in insects. As we learned before that according to the organ responsible for the gaseous exchange between the organism and the medium where it lives, we can find many types of respiration. We learned before that there are 4 types of respiration. Pulmonary respiration, which is relative to the lungs, tracheal respiration, which is relative to the trachea, gill respiration, which is relative to the gills, and cutaneous respiration, which is relative to the skin. Now it's time to answer number 3 in worksheet 21. We say that the trachea is the respiratory organ in the grasshopper. Give the type of the corresponding respiration. So since the trachea is the main respiratory organ in grasshopper, so the type of respiration is tracheal respiration. But how does the gaseous exchange take place in insects? The following table shows the composition of the atmospheric air to that of the tracheal one. What do we mean by the atmospheric air? The atmospheric air is the air that enters the trachea of the insect, while the tracheal air is the air that leaves the trachea of the insect. So how much is the composition of the oxygen gas in the atmospheric air? It is 21%. How much does it become in the tracheal air? It becomes 4%. About carbon dioxide gas. How much is the composition of carbon dioxide gas in the atmospheric air? It is 0.03%. How much does it become in the tracheal air? It becomes 6.5%. Now it's time to answer numbers 4 and 5 in worksheet 21. Number 4. Compare the percentage of oxygen gas in the atmospheric air, which is the air that enters the trachea, to that of the tracheal one, which is the air that leaves the trachea. Keep in mind, when we want to compare numbers, we should use the following terms: either greater than, or less than, or equal to. So the percentage of the oxygen gas in the atmospheric air, which is 21%, is greater than the tracheal one, which is 4%. Number 5. Compare the percentage of the carbon dioxide gas in the atmospheric air to that in the tracheal one. The percentage of carbon dioxide gas in the atmospheric air, which is 0.03%, is less than that of the tracheal one, which is 6.5%. Then how can we explain this variation? What causes the decrease in percentage of oxygen gas in the air leaving the trachea? What causes the increase in the percentage of carbon dioxide gas in the air that leaves the trachea? Number 6. Explain the difference between the composition of the atmospheric air and the tracheal one. Here is the composition of the atmospheric air. We can notice that the atmospheric air is rich in oxygen gas while it is poor in carbon dioxide gas, while the tracheal air is poor in oxygen gas and it is rich in carbon dioxide gas. So what happened at the level of the muscle? Which process occur? The air that enters the body of the grasshopper passes through the trachea and branches through the tracheals, which end with very small air sacs. Here between the air sacs and the muscle, gaseous exchange will take place, so that the oxygen gas is consumed and the carbon dioxide gas is released. Here the process of gaseous exchange takes place directly between the air sacs and the organs. And number 6, when we want to explain how does the gaseous exchange take place, we are going to talk about 3 main events. What happens during inhalation, what happens at the level of the muscles where the gaseous exchange takes place, and finally what happens during exhalation. So during inhalation, the air enters the body of the insect, which is rich in oxygen and it's poor in carbon dioxide gas. So gaseous exchange takes place directly between the air sacs and the muscles, by which the oxygen gas is consumed and the carbon dioxide gas is released. So the tracheal air leaves its body poor in oxygen and rich in carbon dioxide gas. So we said that Gases exchange occurs at the level of the muscles. But do insects have structures that facilitate gases exchange? Yes, here are the air sacs. So the oxygen gas that enters through the spiracles reach the tracheals. Those tracheals end with numerous sacs of thin walls called the air sacs. Answer number 8 in worksheet 21. Number 8. List the characteristics of the air sacs that favor the respiratory gases exchange. Observe the figure here. How many air sacs are found? Do we have only one air sac or many air sacs that are distributed in the body of the insect? There are a numerous or large number of air sacs. What about their walls? Do they have thin wall or a thick wall? Those air sacs have thin walls in order to favor the respiratory gases exchange, so that the oxygen gas can be consumed by the organs and the carbon dioxide gas can be released from the organs to be exhaled outside the body. Gases exchange in humans versus insects. Observe this alveolus, which is the site of gases exchange in humans. So, how does the oxygen gas reach all body organs? Does it go directly from the alveolus to the organs, or it passes through the blood in order to reach all organs? As we learned before that the gases exchange takes place between the alveolus and the blood, where the oxygen gas diffuses from the alveolus to the blood, and then it is transported through the blood to all body organs. But what about insects, where the air sacs are the site of gases exchange? Does the oxygen gas passes through the blood in order to reach all body organs? And does the carbon dioxide gas pass through the blood in order to reach the air sacs? No. Here, the gases exchange takes place directly between the air sacs and the muscles or the organs. The organs consume oxygen gas directly from the air sacs and release carbon dioxide gas directly to the air sacs. Now it's time to answer number 7 in worksheet 21. Number 7. Indicate the difference between the respiratory gases exchange in a grasshopper as an example of tracheal respiration and in lion as an example of pulmonary respiration. In tracheal respiration, gases exchange occurs directly between the air sacs and the organs, while in pulmonary respiration, the respiratory gases are transported through the blood to reach the organs. As a summary, in insects, the main respiratory organ is the trachea, so the type of respiration is tracheal respiration. Gases exchange takes place directly between the air sacs and the organs, by which the organs consume oxygen gas and release carbon dioxide gas. The characteristics of the air sacs that favor gases exchange are large number of air sacs and thin walls. As an assignment, memorize the answers of numbers 2, 3, 6, 7, and 8 in worksheet 21. Thanks for listening and watching. Stay safe.